In this lesson, we will talk just briefly about buffer bloat. We saw an example of buffer bloat in the last lesson where we explored the latency effects of power boost. In the example that we explored, the sender could send at a rate r that was bigger than the sustained rate r without seeing packet loss. Now, if there's a buffer in the network that can support this higher rate, what we'll see is that buffer will start filling up with packets. But this buffer can still only drain at the sustained rate r. So even though the sender might be able to send at a faster rate for a brief period of time in terms of throughput, all of those packets that the sender sent at that faster rate are queued up in line waiting to be sent. As these packets are waiting in this buffer, they'll see higher delays than they would see if they simply arrived at the front of the queue and could be sent immediately. The delay that the packet will see in the buffer is the amount of data in the buffer divided by the rate that the buffer can drain. These large buffers can introduce delays that ruin the performance for time-critical applications such as voice and video. These large buffers actually show up all over the place, in home routers, in home Wi-Fi devices or access points, in hosts, on device drivers, and also in switches and routers. Let's take an example of buffer bloat that we observed in home routers as part of the Bismarck study that I described in the last lesson.